Basically, creating a data set. And Yeah, and mainly kind of, and over the next couple episodes, we're going to kind of jointly work through, uh, well, jointly kind of, I'll show you how I'm creating FlowDB 2.0, which is kind of extension of this precipitation and weather flow forecasting data set. But first, a bit of background. So, I guess the point of this series, and some of the point of it overall is that there are a lot of different, resources out there about data science in general. But one of the skills I still see people lacking a lot in data science, and it's really more of a data engineering skill, but it's a good skill to have even if you're a data scientist, is being able to create kind of high fidelity data sets and work with kind of existing code that deals with existing data sets. Um, so, so basically, yeah, this is going to cover step by step as I kind of go through and create like a better version of FlowDB. And this, even though all this data is from public sources and is focused on like weather and meteorological data, it's the process itself is fairly similar to what you'd see at a corporation. Often, when you go in at a corporation, you have some existing data sets. They might be in SQL or they might be in various APIs, and you have to connect to those APIs and then format the data and get it, in the right state, for machine learning and kind of further data science type tasks. And even if you do have a data engineering team, it's a useful exercise knowing how these data sets are constructed, because then you have like more like better overview of the process, and you can more like communicate easier with your data engineering team since you understand some of what they're doing and going through. So yeah, I guess without further ado, I'm gonna jump into some of this. So basically, the idea of this particular data set was actually all the way back in 2020. We published a paper called FlowDB, which contained kind of the joined together river flow and precipitation data of a large number of rivers in the United States. This was published at like the NERIPS climate workshop. Um, so yeah, if you're interested, you can kind of go see that in the links. I'll throw that up there. Um, uh, but anyways, so that was published, but that data set kind of had a lot of limitations, both from a machine learning perspective and also just in general, like the data was limited. Some of the precipitation data wasn't good, and we'll go over what wasn't the best available, and we'll go over exactly what that means in a second. So, part of the idea now is to kind of construct a better version of that data set, that can like give better forecasts for different river basins um, around the country, and potentially, I don't know, even expand it to other parts of North America, and kind of also maybe have just a general hydrological precipitation data set. So, so that's something that I'm going to look at here, and this is something you would do pretty much similarly on like a company's data set is often like before you even, of course, jump into coding the data and building the pipelines or whatever. You're going to look at what your goals are and kind of what you're aiming to do. Obviously, these will vary a bit from a bit of a corporate setting here, mainly looking to create a data set to power more advanced deep learning models and also, I guess, yeah, potentially publish another paper on the improved thing, but yeah, so, but like obviously in the corporate world, your the goals would align more closely with actual business goals of the company. Um, but besides that, it's pretty similar. So yeah, I'm gonna list some of these out of things I want to do in kind of this updated 2.0. So incorporate Snowtail data, Snowpack. Or the goal is, yeah, incorporate Snowpack data into the data set in some way. So this was a big one. A lot of western rivers are actually fueled more by snow than by precipitation. And even though, some of that should be learned through like the months and stuff, having the snowpack data can lead to like obviously a lot better forecasts. So that's kind of one of the first things. Incorporate snowpack data as a goal. Another thing is to potentially utilize better sources of precipitation. So one of the things the original data set did is it basically just tied together the basin, the river basin, with what was closest, the closest like what was it? Where'd I get? Oh yeah, the closest ASOS, which is basically these weather stations. So I just used whatever was the closest weather station by haversign distance. So, but the problem with that is that like different, particularly when in different mountain ranges and other things like that, different, a weather station, for instance, like just as an example, like if you were in Colorado or something, a weather station might be on one side of the continental divide and like a river basin the other. So in that case, the precipitation at that weather station wouldn't be very useful. So there needs to be some more like holistic way of like better either using multiple sources of precipitation or maybe using kind of a NOAA precipitation map. I already have that down as a potential data source. So in that note, there's also there was a recent model called the Reformer that I think actually took some of those images of these like. So we also kind of want to build this into a data set. For precipitation nowcasting. So like real-time precipitation. So like something that like this model could ingest. Include data or a more type model could ingest. So that's another thing. So potential sources. So I guess those are kind of the main goals. Another bonus goal, I guess, too, is like add soil, maybe soil moisture data. This isn't quite as important as snowpack data in general, or kind of these precipitation maps or better precipitation. Oops. But it could still, I think, overall help for a better data set. Because obviously how much the soil is saturated will influence what the stream flow will be. If it's very dry soil, more rainwater will be absorbed before flows actually begin to go up. Oh yeah, and the other thing is like create an end-to-end pipeline to append new data on at least a daily basis. So FlowDB, the original FlowDB dataset was essentially stale the moment it started, because I think it only had data from like 2009-ish. I forget my own dataset scope now, but from 2009-ish, I think, to 2020 at the latest, I think. Okay, yeah, it was from 2014 to 2019. So ideally, obviously, we'd expand that to the most recent data, but also it'd be good to have a pipeline that automatically appended, new data on at least a daily basis. I think a lot of the data sources are actually hourly, so you could potentially do it hourly, but at minimum, it would probably be good to get some sort of pipeline running at least on an hourly basis. So yeah, that's kind of just brainstorming some goals. Goals might change as you get like deeper into it, but I think those are a good initial list of goals. So then, yeah, once you have some basic idea of goals, you might talk about data sources. So actually, I might add a new thing here too. Current data sources. So basically, currently we use mainly ASOS and USGS for the river flow, and ASOS for precipitation / temperature / like humidity. So basic weather data comes from ASOS and USGS. So data sources, I think Snowtel will hopefully be useful for the snowpack stuff. And then NOAA for the precipitation maps. Oh yeah, another thing would be like, I don't know if this would be more of a bonus, but bonus add aerial, forget how to spell aerial now, aerial imagery of the basin in order, or geospatial of the basin in order for models to learn better yeah, I guess that could potentially be a thing too. So some of these are the data sources. Um, okay, so those are the main ones I think of. Um, so these are areas we probably have to research. But we'll just jot those down. Current code. So I'm gonna link to my current code. And yeah, obviously, like when you're at a company, there probably will be some legacy code or code that's kind of currently that's used for the data processing. So so I do have the old code we used to create like the FlowDB. That's not it. As in like river flow. There it is. So at some point we'll have to go through that code and see what was actually can be still like reused or refactored and what's still useful and what's still not. So yeah, that's basically kind of the first steps. And like you could honestly draw this up on anything. I'm using Confluence now. But yeah, most of your initial, a lot of times, of course, before you even start coding, a lot of it will just be research and kind of note taking about the problem. So I'm gonna look back for this. So yeah, I mean the original data we had, basically we did have this JSON kind of format. This is actually fairly well documented, the different columns. But we have basically hour, date, time, precipitation, the temp, the cubic footage. These weren't that useful. Okay, so that's kind of what we had initially. So then basically what we do is I think we start to usually then dive into looking at some of these additional data sources and then what periodicity they'd have. So particularly when you're constructing a temporal data set, FlowDB was mainly hourly, whereas I don't think these sources are hourly, which raises questions about exactly how to deal with that. So, but anyways, let's look and take like some notes on that. And the other thing is also being able to get like the historical version. Obviously, we need to be able to scrape at least back probably till 2014. And then also the resolution of these, like how like detailed they are. So actually under each of these, maybe I can make this a larger heading or something. Yeah, that's probably better. I'll make these like maybe level 3. I don't need like a huge heading. Level 3, but something to distinguish and then be able to do. And these are or is this hourly? I think we made these hourly, but I think, well, this was hourly. I think the USGS was actually in 15-minute intervals. I can check the original script geological thing. Also, another thing I need to check is they might have changed their API. So I'll just make a note of that. Need to check API and legacy code still scrapes. So yeah, particularly at a company, if you still have like legacy code, then you'll need to pretty much check that still actually runs. So actually that might be a good thing to do now, is check, see if like I can still run some of that. And I don't know if I had like detailed instructions on how the dataset was built. Dataset construction notebook. Okay. Dataset, where the bulk of the data is collected. So I haven't run this, I think, in a long time. Yeah, you can see it was last even edited like back in 2021, so more than 2 years ago. So I should probably check. So get closest gauges. Okay, so this was the function I think that got the lever data. Where is the file that got the stream flow data though? Oh, make USGS data. Site number. Okay, so actually I might just take this function. Oops, no, I don't actually want to run this now, and see if this function would still run, basically, given this. Yeah, so another thing to do also, I'll also do add unit test. Well, obviously if it's a pipeline too, we'd see if it fails. So it would be good to have like tests for individual scraping functions that run daily and alert to API changes. I guess that could be like almost a sub bullet for that. Because yeah, as I said, I don't really know at all if that code actually still runs at the moment, since it was just mainly from a notebook. So that's the current data sources. It might be useful to link to some of this code. USGS function. Wait, was that in the Riverflow notebook? This was build data. Oh yeah, that was. So that actually was in there. So I'm going to link to make USGS data. Now that might be a good example too. But anyways. I forget, can I hyperlink this? Yeah, anyways, this is a good example of why not to use notebooks. Because, code. Oh, I guess I can. Okay. Well, that's good enough. And that, like, will let me link to that function again. So. Then I guess, yeah, once I test it. Oh, so that, I guess I can add this as an action item or something. No. How do I get that there though? I wonder if I can just make a checkbox there. Okay, I don't need a fancy thing. So I'll just make a checkbox there to test that that function still works. So that's one of the things I need to do. Then maybe, yeah, this would be verify raw data is in. Okay. So I'll just use these little boxes and put an X next to them. When I get it done. Okay, so that's on the legacy. Similarly, yeah, we need to verify. Basically similar thing here. Test. What's this one called? So basically, yeah, this notebook. Yeah, I mean, it might make sense just to run through this whole notebook again. And then I could check these off. So anyways, that's kind of the legacy code piece. Related to this goal, these will probably be made. My guess would then these be made. These functions will be taken. Well, I mean, the haver sign, well, most of these functions will then be taken, I think, and put in a DAG, probably using Airflow. My guess is to do this end to end, would probably use Composer on GCP. Though I also don't want to create like a huge bill for this. So okay, so that. Okay, but assuming these still work, then what we really need to do is research these and kind of look at how we would potentially create scraping functions. Well, before that, even just write out some more info on them. So, and look at that quickly. Persip. So this is, I guess this is what Noah looks like. I don't know what the exact resolution you can get. Current view. 1 day observed precipitation. So that's good. But does this have an API I could like call? Something I would need to see. I wonder NOAA precipitation. No API. Maybe history. We want to like essentially scrape historical images, probably at a specific resolution. It looks like on a daily basis. I don't know what this is. For the current view. So they do have this little map UI, but I don't know how that would work with like an API. Let me see. Download. Oh, maybe this would be more helpful. For full area day, July. Let's do some random day. Okay, I need to clarify what the fuck does that mean? Oh wait, they have an hourly. But I don't know if it's historical though. Okay, let's see what this makes. I have no idea what this is actually going to make. Whoa. Maybe preview doesn't open .tiff. Or that's a geotiff. Do I even have anything to open geotiff? Open. Okay, I just want to open a geotiff file though. Oh, maybe here. Let's see. Is this anything useful? Might be useful. Loading raster. Okay. Well, nothing's really happening. Okay, I don't know. Look into hourly. I'm gonna save that link though. Okay, I mean, I might need to get a reader for this, so that might be something to look into. What's net cdiff? Not actually familiar with many of these. Okay, netcdiff. I think they have some extensions for these in Python. Okay. So maybe I can use Python with this. So yeah, here's where, you know, you might create like some just notebook of like exploratory analysis of some of this data. Something like that, or create equals true. What? I thought I named that anyways. I don't know how we'd scrape that. I mean, assuming these files are actually useful, we would still need to obviously create code to scrape it programmatically. Okay, geotiff. Anyways, I guess that's something to figure out. So API. Well, there might be flooding in New England. Yeah. Yes. No, I don't care about the forecast. Examples. Wait. Let's see. Radar station specification. Oh yeah, history. So that doesn't look. AHPS. Search AHPS API. Maybe this thing's useful. No, I don't care about that really. HPS maps. God, so I don't think. Yeah, I'll have to look more into that. I mean, it's always possible to just scrape using this, but that would be a real pain in the ass. Oh, you can use widget. New window. Wait, they say to use widget, but they don't say what the URL would look like. I guess. And what is this URL it's generating? Guess we could look at that. Just They're basically just saying use vanilla wget. So maybe, no, I want the URL, you stupid thing. I don't really care about that specific file. Okay, so it looks like, yeah, we could use, this. But where's the date then? I don't know where we changed the date in this. I don't know where the date is though in that. Or is that not using the date? Oh, that's not good. I don't think that's actually using the historical thing. Oh shit, that means that, yeah. I don't think that's, so hourly, yeah. I think they only have daily for historical. So yeah, it looks like for that, I think, the most we'd get out of that would probably be daily is my guess. I mean, I might look into that a bit more, but I don't think that would change. Okay. So precipitation analysis. In any case, yeah, let's see if we could grab one of these URLs would look like. History show. Sync then. Yeah, so that has a date field. Sync, edit link. Wonder if you just toggled this to hourly, would it work? Range 1 hour, probably not. No, I probably wouldn't. Okay, so it looks like we, write code to sub in whatever date we're looking at. There's still a question about then the resolution. For that, I need to probably explore what those files would be. So I'm going to look at libraries for that actually. So I don't know which is better, GeoTIFF or, let's see, GeoTIFF Python. GeoTIFF Python. Raster IO. So Raster IO by Mapbox might work. So this will be like an exploratory analysis notebook of some of this data. So here. show FP. Wait, what the heck? Let me see that. Oh. Yeah, that line got there. Oh yeah, that's how it would look. So let me try this. Pip install raster IO, and then we can try getting that, whatever that is. Let's see if that works. Why little? Okay, so that did work. Okay, let's try to get that thing. We said to use widget, so we'll use that. I don't know why they couldn't build an actual API. That would be nice. Okay, where'd I put those URLs? Okay, we'll try this shit. Widget. Format tar. I'd rather not actually deal with a tar file. Actually, what if we just do like full resolution image? Honest. Okay, I'll just try the geotiff. That might be better. Yeah, if it's a geotiff, then maybe I can then take it and then like separate it based on resolution to like the different areas. Okay. Format tar. Example dot tar. So what is it? Widget O. Then wait. Isn't it this comes after? I forget. Oh shit, that's not what I wanted. Internal server error. Widget O. Is that right? Need that. Oh, there we go. Example tar. I guess we need to untar it now. So I guess, yeah. So we need to untar it. Okay. Wait, no, shit. Okay, how do I untar? Untar file collab. Okay, let's try this shit. What do we call it? Example.tar. What? No, I need one of these. Yes, and then we just do content. Example. what the hell? Where did it download that? Copy path. Oh. No, it would be slash content. Okay, cool. GRB2. Wait, these are GRB2. I thought we were doing GeoTIFF. Shit. Download. Let me go back to that. I thought we were looking to do GeoTIFF. Yeah, what the fuck happened with that? No, I'm gonna have to get this URL. Oh wait, yeah, that's the upper notebook. Okay, let me just try looking at this. Type file, oh yeah. That makes sense. And let me try. Now, of course, nothing is going to be there. Okay, yeah. Raster.io. Okay, we're talking about opening GeoTIFF Python raster.io. Oh yeah, someone had a quick example. Really getting pissed. Oh, all you need to do is that, I guess. So hopefully this is pretty simple. Wait, no. Yeah, no, that's this notebook. To open it, at least. Okay, let's just do... What? Yeah, there should be one there. Oh, here. Copy path. So this should work, I guess. Why is it empty? I would hope it wasn't be fucking empty. Wait, I saw I would get some like map of the US and persip or something. Okay, I don't actually know what this stuff is saying now. God, those people outside are annoying. Fucking making a noise. Yeah. I don't know. Okay, well, I'm gonna explore more about these TIFFs, GeoTIFFs, and what they actually mean. Yeah, I think that's a good kind of first episode for now. But yeah, I think next week we'll circle back and look more at some of these images and what they actually mean. Yeah. But yeah, so again, this is working towards on this NOAA front. But the goal of this again in that notebook would then be to get like a precipitation map at a certain spatial resolution. I'm not sure what that would be yet, because I'm not sure how detailed these images are, and then write code to, automatically scrape and get these images for the time period we're looking at. So let me see, download day geotiff band 1. Okay. Prism normals, departure from normal. What the heck is normal? So these are all things like we'll have to look into, like what they actually mean with normal precipitation. Normal, band free, departure from normal. So yeah, that's something we'll have to look at. Percent of normal. So this is what exactly each of these files mean. Because yeah, it seems like they extracted them. Okay, that's Alaska. Colonists. Precip day 1. So what's colonists, I guess, too? Oh, continental US, I guess. That's what that would mean. But I don't see any precipitation on this. So, I don't know. Yeah, it looks like there's nothing here. Wait, raster. Oh wait, maybe band? Okay, I don't know what the fuck. Wait, what if I don't want to read bands? Show. What if I just want to show the whole image? Oh, I guess you could just do show image. See if that helps. What? That's even more confusing. It doesn't even look like the continental US. I don't know. Do you think that looks like the continental US? Okay, anyways, yeah, I'm gonna explore these more. But that's kind of like, sort of summarize, like, I guess tonight we outlined some of the goals for what the data set should entail. We looked a bit at some of the code and the current functions to get the code. We also started outlining and started exploring some of the additional data sources we'll scrape and put into the new code. So, yeah, that's kind of what we looked at and examined tonight. So yeah, next week I think we'll have a longer episode and we'll dig a bit deeper into verifying these sources and I'll give some updates on what I found with these precipitation maps. Now obviously this is kind of obviously very heavily focused on this geospatial data and this this data from Weather Service and all these different government agencies. So some of this is definitely this task specific, but it's kind of similar in that, like, in a lot of tasks, you will have to do this kind of like exploratory analysis on like what data is available, how often is it available. It might be in weird formats like this. It might even be in some company formats. So you'll have to investigate and kind of prune through your company's documentation of the data and kind of just work out notes and write kind of mini scripts as you go. And then eventually, as you'll see, you'll have to refactor those into actual pipelines to get the data. But that's kind of the gist of it, of constructing a useful data set. So okay, so yeah, I think we'll end that for now, and then I will see everyone next week on this data engineering. Oh, but also besides data engineering, we're also actually having multiple episodes. So this is focused on data engineering. Others are going to be focused on actually forecasting and using FF to actually forecast other types of data. And then we're also going to have kind of an ML ops hour where I'll focus on just taking already trained models. Some of them might not even be time series models, but any other types of models and deploying them. So make sure you stay tuned for those as well. Okay.